Hello everyone. In today's lecture, we will discuss regarding the problems on a cantilever beam. So problem is that cantilever beam of span 2 meter carries a point load of 5 kilonewton at free end. Draw SFD. So this is our figure. With this is a beam. A beam whose having one end is fixed, another end is free. That is A end is fixed and B end is free. The beam having span is 2 meter. Okay, and then we have to draw SFD and BMD. So for that, fixed side having support reaction, that is upward support RA, and one point load is at free end, that is 5 kilonewton, which is going in downward direction. So our first step is, so I'll take algebraic sum of all the vertical forces. So RA is equal RA which is going in upward direction, so RA and 5 which is going in downward direction, so minus 5 is equal to 0. So RA is equal to 5 kilonewton. We already discussed in simply supported beam how to calculate summation Fy. So summation Fy means take only vertical forces. Then step 2, calculate values of shear force. Then here we were starting from the left side. So first, shear force at A of left is 0, A of right is equal to 5 kilonewton, B of left is equal to 5 kilonewton, B of right is equal to 5 minus 5 is equal to 0 kilonewton. Means first point is A of left, means the section line is draw left of the A. So should draw here left of the A. Now look left of that section line. In left of the section line there is no force, so consider there the value of A of left is 0. Then come towards A of right, means this section line now draw right to the A, means draw here. Now look left of that line. While we looking left of that line, there is only one force, which is RA force, which is going in upward direction. So it is plus, so consider plus 5. Then second, B of left, means this section line is draw left of the B, means you should draw left will be like you should draw here or you should draw here. Anyway, consider line this available in this here. Now look the left of that the line. While looking left of the line, there is only one force, which is the RA force. The RA which is going in upward direction, so consider as a plus RA. And last is B of left, means B of right, means this section line is now draw right of the B. Now look left of that section line. While looking left of that section line, there are only two forces, that is RA and B. The RA which is going in upward direction, so consider plus, it is plus 5, and B which is going in downward direction, so minus 5. So plus 5 minus 5, so it is 0. So this is about the values of the shear force. The next step number 3, draw SFD and BMD. While drawing SFD and BMD, first draw the baseline A, C, B. Then the A of left having 0 and A of right having plus 5, so plus 5 value, so plus 5 draw vertical line above the baseline. B of left is also plus 5, so B of left, this line plus 5 line, vertical line should be draw vertically. Now in between A and B there is no force, so it should be joined in horizontal line. So this is about shear force diagram. Next, step number 4 and 5 is calculate the values of bending moment and drop bending moment diagram. Here important note is that in cantilever beam, bending moment is always start from the free end. In last few lectures I was told that whenever we taking bending moment values, you should take any side, that is you should take from left side or right side. It is possible in case of only simply support beam and overhanging beam, but in case of cantilever beam, bending moment is always start from the free end, not left end or right end. It is always start from a free end. Suppose in cantilever beam left end is fixed, then right end is free. The bending moment start from the right end. Suppose in cantilever beam right end is fixed and left end is free, then you should start bending moment from the left end. So this is a very important note. In cantilever beam bending moment always start from a free end. So first point is B, because B end is the free end. So bending moment at B is 0, then bending moment at A is equal to -5 into 2 is equal to -10 kilonewton. Bending moment of B is 0. This is because this is a free end. Then come towards the A point. Like here come bending moment of A. This is the bending moment of A. While taking bending moment of A, you should look towards the free end. While we looking towards the free end, in free end there is only one force, that is 5 kilonewton, which is going in downward direction. So consider -5, and distance is B to A distance is 2 meter. So -5 into 2, it is -10 kilonewton. Then draw bending moment diagram. While drawing bending moment diagram, bending moment of B is 0 and bending moment of A is -10, and then draw vertical line below the baseline and should be joined with inclined load, because there is in A and B there is no load present, so it should be joined with inclined line. So this is the first problem of the shear for in cantilever beam. In cantilever beam, is important note is that in cantilever beam bending moment is always start from a free end. In second problem, is that a cantilever beam 3 meter span has point load of 20 kilonewton at 2.5 meter from fixed end. Draw SFD and BMD. So this is our cantilever beam. This is a cantilever beam whose one end is fixed, that is RA end is fixed and B end is free. Okay, the beam with 3 meter span. So beam having 3 meter span has point load of 20 kilonewton at 2.5 meter from fixed end. From fixed end 2.5 meter distance, at that distance having 20 kilonewton point load. Okay, then we have to draw SFD and BMD. So for that drawing, first you should have to calculate value of RA. For calculating value of RA, use summation Fy is equal to 0. Summation Fy means consider only vertical forces. There are two vertical forces, one is RA and second is the 20 kilonewton. So RA which is going in upward direction, so consider plus RA. So 20 it is going in downward direction, so consider -20 is equal to 0. -20 move towards the 0, so RA is equal to 20 kilonewton. Then second step is that calculate values of the shear force. The shear force values are A of left is 0 kilonewton, means now section line is draw left to the A. So draw section line here. Now look left of that section line, there is no force present, so A of left value is 0. Then second, this is about A of left. Second, A of right is equal to 20 kilonewton, means that now this section line is draw right to the A. Should draw this line here. Now look left of that section line. In this area there is only RA force is present, which is going in upward direction. So consider one force RA which is going in upward direction, so it is plus 20 kilonewton. So this is about the A of right. Then third is C of left is equal to 20 kilonewton, means this section line is now draw left to the C. While drawing the left to the C means you should draw this lines Here same. Now look, left of that line there is only one force Ra which is going in upward direction, so it is plus 20 kilonewton. This is about the C of left. Now C of right is equal to 20 minus 20 is equal to 0 kilonewton. Means this section line now draw right to the C, should draw here line. Now look left of that section line. While looking left of that section line, there are two forces are present. First is the Ra and second is the C. The Ra which is going in upward direction, so consider plus 20. C which is going in downward direction, so consider minus 20. So plus 20 minus 20, it is 0 kilonewton. This is about C of right. Then next, shear force at B is equal to 0 kilonewton. On the B there is no vertical force is present, so there is no necessary to consider B of left or B of right. Only consider shear force of B, means this vertical line is drawn directly on the point B. Now look left to the B. While looking left to the B, there are two forces Ra and C. The Ra which is going in upward direction, C which is going in downward direction. So consider plus 20 minus 20, it is 0 kilonewton. So this is about the B, and this is the value of the shear force. Now draw shear force diagram. While drawing shear force diagram, first draw baseline A, C, B. The A of left is 0, A of right is plus 20 kilonewton. The values of the plus draw above the baseline, and minus value should be draw below the baseline. So plus 20 draw above the baseline, means this 20 kilonewton line is vertical line on the A. C of left is also 20 kilonewton, means this line is vertical line is on the C, 20 kilonewton, and B's value is 0. Now in between A and C, there is no force are present, so it should be joined with horizontal line. So this is a horizontal line, and this is about the shear force diagram. Then next is calculate values of bending moment and draw bending moment diagram. In cantilever beam, in one important note is that whenever we start the bending moment in cantilever beam, the bending moment is always start from a free end, not left end, right end. It is always start from a free end. It is very, very important note in case of cantilever beam. So bending moment of B, first bending moment of B is equal to 0 kilonewton. Here B is considered because of B which is present at the free end. This is B which is present at the free end. Then next is bending moment of C. It is also 0 kilonewton. How it is come? So now we have to calculate value of bending moment of C, means the value of here. Now look the free end side. While looking free like right side, there is no force are present, so bending moment of C is also 0. Then next, bending moment of A is equal to minus 20 into 2.5 is equal to minus 50 kilonewton, means that now come towards the point A. Now look towards the free end. While looking towards the free end, there is only one forces are present, which is a 20 kilonewton, which is also going in downward direction, so consider minus 20, and now distance is 2.5 which is present between Ra and C. So minus 20 into 2.5 is equal to minus 50 kilonewtons. So this is about the values of the bending moment. Now draw bending moment diagram. While drawing bending moment diagram, first draw baseline A, C, B. In B having 0 kilonewton load, C having 0 kilonewton load, and A having minus 50. Minus 50 means should drop below the baseline. So this vertical line is about minus 50 kilonewton. Now join AC. In between A and C there is no load, so it should be joined with inclined line. So it is joined with inclined line. So this is about the bending moment diagram. This is the second problem. Now come towards the third problem. In third problem state that a cantilever beam of span 4 meter carrying 2 point loads of 10 kilonewton and 30 kilonewton at 1 meter and 2.5 meter from free end. Draw SFD and BMD. Means that, consider this is a beam, horizontal beam. The beam which is having cantilever beam means a beam whose one end is fixed here, left end is fixed and right end is free, that is B point is free, A point is fixed. Okay, and then span is 4 meter. This is the span, A to B span is 4 meter. Then carrying 2 point loads of 10 kilonewton and 30 kilonewton at 1 meter and 2.5 meter from the free end. Means the 10 kilonewton is present at 1 meter distance from the free end. Means free end is at the point B is the free end. From the free end up to 1 meter there is a 10 kilonewton force, and from the free end to 2.5 meter from this distance, at this point there is a 30 kilonewton load is present. This is about the figure of a cantilever beam. Now first step is calculate summation Fy is equal to 0. Means here RA is going in upward direction, so consider plus RA. 30 which is going in downward direction, so minus 30. 10 which is going in downward direction, so RA minus 30 minus 10 is equal to 0. So minus 30 minus 10 is equal to minus 40. Minus 40 move towards the 0. So RA is equal to 40 kilonewton. Second, the values of the shear force. The first value A of left is 0. Second, A of right is equal to 40 kilonewton. Means that this section line, first section line A of left means first section line, draw left of the A. Look left of that section line, there is value is 0. Now this section line is draw right to the A, means you should draw here. Now look left of that section line, there is only RA force which is going in upward direction, so plus 40. Okay, then C of left is also 40 kilonewton. Means this section line is draw left of the C. This line consider here at the same point. Now look left of that section line, there is only RA force, so the value is C of left is equal to 40 kilonewton. Then C of right is equal to 40 minus 30 is equal to 10 kilonewton. Means that section line is draw right to the C. You should draw line this here. Now look left of that section line. While looking left of that section line, there is a RA force and there is a C force. The RA force which is going in upward direction, so plus 40. C which is going in downward direction, so minus 30. So plus 40 minus 30 is equal to 10 kilonewton. D of left is also same, which is plus 40 minus 30 is equal to 10 kilonewton. Means this section line is considered at the same point. Now looking left of that section line, there are also same forces RA and C, so consider the same value, the answer is also same. Then D of right is equal to 40 minus 30 minus 10 is equal to 0 kilonewton. Means that this section line is now draw right to the B. Then now look left of that line, there is RA force are present, C force present, D force present. RA which is going in upward direction, C which is going in downward direction, D which is going in also downward direction. So RA plus 40 minus 30 minus 10 is equal to 0 kilonewton. So this is about the values of the shear force. Now draw shear force diagram. While drawing shear force diagram, first to draw baseline A, C, D, B. Now value of A of left is 0. A of right is equal to 40 kilonewton. Means you should draw vertical line of the 40 kilonewton. Then C of left is equal to 40 kilonewton and C of right is equal to 10 kilonewton. Means that dotted line shows value of 10 kilonewton. That full line shows value of 40 kilonewton. Then d of left is equal to 10 kilonewton. This is about the d of left is 10 kilonewton. Okay. In between A and C there is no load. It should be joined with horizontal line. In between C and D there is also no load, so it should be joined with horizontal line. So this is about the shear force diagram. Then come towards the values of bending moment and bending moment diagram. So while calculating bending moment values in cantilever beam, so always start from the free end. So B is the free end, so bending moment of B is 0. Bending moment of D is also 0, because while we coming at D, okay, now look towards the free end. While looking towards the free end, there is no force are present, so bending moment of D is also 0. And bending should come at the point C. Now look towards the free end. While looking towards the free end, there is only D force is present, and D which is going in downward direction. So minus 10 and distance 10 to 30 kilometer distance having 1.5. So minus 10 into 1.5 is that minus 15 kilonewton. And last is bending moment of A is minus 10 into 3 minus 30 into 1.5 is equal to minus 75 kilonewton. Means that now you come at a point. Now look towards the free end. While looking towards the free end, there are two forces, 30 kilonewton and 10 kilonewton. 30 kilonewton which is going in downward direction, so minus 30 into distance is 1.5, means A and C distance having 1.5 meter, so minus 30 into 1.5 meter, and 10 kilonewton which is also going in downward direction, so minus 10 into distance is that 3 meter. In between RA and D having 3 meter distance, 1.5 plus 1.5 is 3 meter distance, so minus 10 into 3, so it is minus 75 kilonewton. This is about the values of the bending moment. Now draw bending moment diagram. While drawing bending moment diagram, first draw baseline A, C, D, B. This is the baseline. Okay. Value of B is 0. This is 0 value. Value of D is also 0. Value of C is equal to minus 15, means this is minus 15 kilonewton. Value of A is equal to minus 75 kilonewton. This is minus 75 kilonewton. Now join A and C. While joining A and C, in between A and C there is no load, so it is joined with inclined line. C and D is also having no load, so it is also joined with inclined line. So this is about the diagram of the bending moment. Okay, so this is the third problem of the cantilever beam. Now come towards the fourth problem. In a fourth problem, a cantilever beam is loaded as shown in figure. Draw SFD, and here is a cantilever beam whose one end is fixed, the RA end is fixed, B end is free. 40 kilonewton load which is act on that beam with a distance of 1 meter from the left end. UDL of 20 kilonewton per meter is present at a distance of 1.5 meter. Okay, so now we have to calculate SFD and BMD. So first convert UDL into point load, means should draw here vertical line, should draw at the center of that UDL, because it's UDL having 1.5 meter, so you should draw this distance is 0.75 meter and this distance is 0.75 meter. While converting UDL into point load, you should use the value of 20 into 1.5. You should here taking value 20 into 1.5. So RA which is going in upward direction, so plus RA. 40 is going in downward direction, so minus 40. While converting UDL into point load, the value is minus 20 into UDL distance is 1.5. So after calculating, the RA is 70 kilonewton. Then calculate shear force value. The first value is A of left is equal to 0 kilonewton. Second, A of right is equal to 70 kilo Newton. Means the section line is draw right to the A. Means you should draw line here. Now look left of the section line. There is only one force, which is RA force, which is going in upward direction. So plus 70. Then C of left is also same, that is 70 kilonewton, because this section line is present at same point and looking also same direction. At the left side there is only one force, which is RA force. So consider same value, C of left 70 kilonewton. Then next C of right is equal to 70 minus 40 is equal to 30 kilonewton. Means that now this section line is drawn left right to the C. Means you should draw here. Now look left of the section line, there are only two forces, RA and C. RA which is going in upward direction, so consider plus 70, 40 which is going in downward direction, so minus 40. So plus 70 minus 40, it is 30 kilonewton. And last is B, shear force of B is equal to plus 70 minus 40 minus 20 into 1.5 is equal to 0 kilonewton. Means that now this section line is drawn on the directly B point. In B there is left or right is no necessary, because in B there is no vertical load is present. Now look left of that section line. This is a section line. Now look the left of that section line. There are RA force present, point load is present, and UDL is also present. So RA which is going in upward direction, so plus 70, 40 which is going in downward direction, so minus 40, and UDL is also going in downward direction, so minus 20 into 1.5. So it is also 0 kilonewton. So now draw the shear force diagram. While drawing shear force diagram, first draw ACB baseline, then 70 kilonewton. This is the vertical line of the 70 kilonewton. Then C of left having 70 and 30 kilonewton. The dotted line shows 30 kilonewton and vertical line, full vertical line shows 70 kilonewton. Okay, now join this in between A and C. In between A and C there is no load is present, so it should be joined with horizontal line. Okay, in between C and B, there is a UDL is present, so it should be joined with inclined line. This is the inclined line. This is about the shear force diagram. The next is a bending moment value and bending moment diagram. While drawing bending moment values, in cantilever beam always start from the free end. So here free end is that bending moment of B is equal to 0 kilonewton. Bending moment at C is equal to minus 20 into 1.5 into 1.5 divided by 2 is equal to minus 22.5 kilonewton. And bending moment of A is equal to minus 20 into 1.5 into 1.75 minus 40 into 1 is equal to minus 92.5. So first is bending moment of B. In cantilever beam always start from the free end, means now section line is drawn on the B. Okay, bending moment of B, we have to calculate values of bending moment of B. Now look towards the free end. While looking towards the free end, there are no forces are present in free end, so bending moment of B is 0. Now come towards the bending moment of C. Bending moment of C's value is that, okay, bending moment of C. While taking bending moment of C, look towards the free end. In free end there are UDL is present. Okay, so UDL's while converting UDL into point load, the value of the point load value is 20 into UDL distance is 1.5 meter. So 20 into 1.5 minus 20 minus, because going in down, it is going in downward direction. So minus 20 into 1.5. Then next divided by 2 means that this vertical line which is present at the center of that UDL distance. So this distance is, now we have to calculate this distance. For calculating this distance, taking 1.5 divided by 2 because it is center. So 1.5 divided by 2 is considered here. So after calculating this, we got answer of minus 22.5 kilo Newton. Then next, bending moment of A. Bending moment of A. Now this section line is come on the A point. Now look towards the free end. This is a free end. While looking towards the free end, there are two forces are present. First is a point load and second is a UDL load. So first consider point load. So point load which is going in downward direction. So minus 40 into distance between 40 and A is 1 meter. So minus 40 into 1. This is about the minus 40 into 1. Now minus 20 into 1.5. Now second load is UDL. The UDL is converted into point load. The point load which is going in downward direction, so it is minus. Then converting UDL into, while converting UDL into point load, the value is that UDL's original load is 20 kilonewton and UDL's original value distance is 1.5. So minus 20 into 1.5. And this is about the minus 20 into 1.5. The next is distance 1.75. While we are taking bending moment of A, so distance between bending moment of A and this point load is that we are already know the distance of the RA to C is 1 meter, and we know the distance of C to this vertical point load is half of the 1.5 meter, that is 0.75. So 1.5 plus 0.75, that is 1.75 meter. After calculating this, we got answer of minus 92.5 kilo Newton. Now draw bending moment diagram. While drawing bending moment diagram, first draw A, C, B baseline. Value of B is 0. Value of C is minus 22.5 kilonewton. Negative value should be dropped below the baseline, and this is value of minus 22.5. Then bending moment of A is minus 92.5. This is minus 92.5. Now join AC. In between A and C there is a no load is present, so it should be joined with inclined line, and CB having UDL, so it should be joined with parabolic curve. So this is about the bending moment diagram. Okay, so these are the three problems in this lecture. We will discuss the three problems of cantilever beam. Thank you.